So a little bit about the farm. It has two major components. One is a therapeutic work environment for the village, and we have a sort of micro farm within the farm. The other project that we're involved with is a blend of exploration and research. What we're trying to do is explore how soils behave as a system, as an organism. We're talking about some of the soil monitoring work that's being done today, which is techniques that have had some pretty profound impacts on soils in a very good way. It's actually made most of us who are involved in this feel as though there's a hope for dramatic regeneration of landscapes.
What you see here is the hardware manifestation of the soil information system. It's a lot more than just hardware, and there's a lot going on behind the scenes with the software analysis. What we have is what we call the surfer and the diver. The surfer because it gets generally surface level information, non-invasive, and the diver because it actually sends sensors into the ground. What the surfer has, along with the diver, is a survey-grade global positioning system and an electromagnetic sensor. And if you look and you can see this yellow tube is an electromagnetic sensor. This particular sensor sends electromagnetic waves down into the soil, and it measures the time that it takes to go from the front to the back. It goes about 4 feet down into the ground, and the information from that is fed through the wire into the data acquisition system that we have here, the software, that integrates in real time as we're moving through the field, the position on the landscape, not only in the X and the Y, but also the elevation, which is really important. So the software, as we're driving this surfer through the field, is integrating the topography information, the GPS, with the electromagnetics. You can do typically, say, 200 acres a day with this particular system. The software then processes that. It's all done in the field. So all of these processes that would normally take weeks back in the office, we've developed the software so that it happens within seconds. That information is then sent over to the diver so that the smart sampling locations can be identified. This is the diver. What we've done here is we've taken a traditional soil coring machine and added about 200 pieces and parts from different places and turned it into a soil sensing device. It can still take core samples, and we use it to take core samples, but there's a lot of other stuff going on here that allows us to do our intelligent mapping. You can take this and you can mount it on track vehicles, you can put it on a truck, you can put it on a tank, doesn't matter. So we finally developed these anchors, and it was a huge step for us. And Zach will show you when we do a test, but they auger into the ground. There's one on each side, and that's how we hold ourselves down when we push in. So, you have here is one of our sensors. You have force on the tip, friction on the sleeve measurement. You have moisture and electrical resistivity. So we have 4 independent sensors as well as ratios of all of those, plus unique information on whether it's increasing, decreasing, or staying the same. We end up with dozens of independent attributes that we can use then to characterize the different soil properties. Now we've pushed this in the ground about 20,000 places on 4 continents around the world, and every time we do that, we get smarter.
And so we had this opportunity on this farm here to get a really good, solid, scientific baseline of what our soils look like in our landscapes, and then start to try to apply some of these new practices and see what happens.